having the 3DWOX1 for some time now for a review, I thought it was time to move on to some different materials. In this case, you see here, this is PETG. And I want to do this video sort of as a collaboration with the rest of you users out there so we can share some settings. I have settings that I think I've tweaked pretty well for ABS and PETG and some open source filaments, and I'll share those Simplify3D profiles in the link below. But I want to just show you some of the things that I've done along the way to get these results. Of course, the very first thing I did was level the bed. If you don't start with a level bed in all directions, you might as well just give up. So go through this process, make sure your bed is level, make sure you're happy with it, then we'll proceed. The next thing I did was set the Z offset. This is the distance between the extruder nozzle and the bed. Now it comes probably 0.25 millimeters from the factory, and I've typically left it at that, but I was surprised this time to find out that using a business card, a standard business card, sliding it between the nozzle and the bed, you want to feel just a little bit of resistance. Keep adjusting this 0.25 down and hitting move and save and checking that until you have it set so that the business card just feels resistance. I was surprised to find out that mine actually on this machine is now set to 0.05, which is a little tighter than it's been on the other machines I've used. Now let's take a look at how I started to do my settings in Simplify3D to set up this profile. I created one called 3DWOX1 using the Sindoh filament, and I tried to match what the parameters were that Sindoh used in their 3D desktop software as close as I could. If you look here, standard settings for the extruder, and again, I'll put these profiles, I'll put a link to them so you can just download them and then tweak them as needed, and let me know if you disagree with some of the settings. But extrusion multiplier of 1, 0.2 layer height, and here your initial layer width. Again, this is just emulating what Sindoh used. I think one of the important things that I found out was measuring the bed temperature on this new 3DWOX1 when I used my infrared measuring temperature gauge. It seems like it's off by about 5 degrees. So if I want 60 on the bed, I have to set the temperature at 65. Bump everything up 5 is what I did. Temperature of the nozzle seemed to be okay. The cooling, I'll show you how I did it in the G code, but for the first layer for PLA it's 0, and then you gradually increase it to 25 up to 50% for your cooling fan. And this is where these are at 0. This is where you have the script I copied from inside the code, the G code that Simplify generates, or Sindoh generates on their desktop software. And all this is kind of standard, but look at this. This was curious to me. After we've already set our Z gap, the Sindoh software always offsets the Z by 0.15 millimeters before it starts. And you could say, well, that's to smash down the first layer and whatever. But, you know, back here, we could do that in first layer settings for the height. So anyway, you have to be aware of that. I've included it here because Sindoh does it and it works out okay, but just remember that. Negative 0.15, it smashes it down. That's almost a layer, you know, in the 0.2 layer. And here's where you just have to do this. You do layer 0, fan off, and you do that little line that they pull across from the upper corner to kind of extrude, and then you fan. You're forcing the fan to be off. If you don't do this, the fan will come on at the wrong time. So it's for layer 0, layer 1, the fan's off in my script here. And then, you know, like I said, it'll take over. And then the cooling, the fan will come up to 25% and 50% after that. So just use this. I like the single extrusion walls under advanced here. And the speeds, I keep at 40. And the first layer, 25%, so down to like 10 millimeters per second. Okay, but the point of all this is, because you can download this, but just notice how that's set up. I started out by getting this thing to emulate the Sindoh desktop software. Now, when I go over to ABS, okay, I've bumped the extrusion multiplier up to 1.1. I'm trying to think, you know, maybe something changed here. Obviously, the temperatures would change. Again, I went 95 to assure a 90 bed, or close to a 90 bed. 230 on my nozzle temperature. fan off all the time. So again, here in the script, this is still this minus 0.15 we talked about to squish it down, but fan off, and then layer 1, layer 2, you know, just this assures that once you get past here, the fan will be off the whole time because we're in ABS here. Speed's probably the same and advanced the same. Okay, now that was for the Sindoh. Let me see if I have something to show you on that, some pictures to show you on that. Now you're going to get tired of seeing this print in my videos. It's an Arduino case, it's the top of it, and it's a good test print because it has these fine lines on it and it has to lay flat and it has a solid bottom and these screw bosses. But anyway, this is eventually from the ABS that I printed from that profile I showed you. The quality was pretty good here. It was the first print after trying to set that up. It's very strong. And here's another ABS print that I did while I was tweaking the settings. Notice down here there was some warping. It was pretty many solid layers of ABS there though, and I think I had the bed set at the 90. But again, I don't print a lot of ABS, and to be fair, you know, there's no glues or hairspray or anything on this. It pops right off. And this is Sindoh's ABS filament, but it's 2 years old and I haven't used it, so there could be a problem there, but I'm pretty happy with this result. I typically don't print in ABS, but it just shows you another example. Now let's talk about this extrusion width and layer width. Take a look at the space between these extrusion lines here. This is 0.4 extrusion width and 200% first layer width. And my understanding is that 200% not only means 200% of the amount of filament extruded on that first layer, but also the lines are twice as far apart as they would normally be. Comment on this below. This is my understanding from Simplify3D online as well as some people online that that's the way it works. Now let's look at the next one. Now the only difference in this one is I set the extrusion width to 0.5 instead of 0.4. The nozzle diameter is 0.4 on both of them, and the first layer width is 200%. But this is just setting the extrusion width to 0.5 on here instead of 0.4 on the previous one. Now maybe this was just some kind of catastrophic failure that's coincidental, but I have documented the only difference on this one is I set the first layer width to 150% instead of 200%. So these things can make a difference. Again, this could be coincidental. Maybe something went wrong. Now it should be noted that when I tried to use the Sindoh desktop software to print ABS, this is what happened. The previous ones I showed you were Simplify3D, but this is with their software. It's a beautiful raft, but then when it tried to print on top of it, it just didn't adhere. Also with the Sindoh software using ABS, I didn't get a very nice finish, and I did get warping down here. So Simplify3D is definitely printing ABS better for me at this point. It was then time to move on to trying some open source filaments. So I created a new profile for Hatchbox, which I purchased, Hatchbox PLA. And if we just compare this, it's similar to the Sindoh for a lot of the settings, but some of them I tweaked a little bit. I believe the first layer on the Hatchbox is squished down 90% and a 150 layer width, whereas on the Sindoh, it was 100% and 200. This is what Sindoh recommended. Like I said, their filament I'm using is what came from them, but the Hatchbox, I found I tweaked these a little, was better. Also on the Hatchbox, let's see, I got the temperature set at 65 for the bed and 195 for the extruder. On Sindoh, it was 65 and 200, so pretty close there. Let's look at the cooling, 25 and 50, right? I think the scripts are slightly different. In the Sindoh, we went Z offset of 0.15 and we had fan off and fan off. When we went to the Hatchbox, we still had the offset of that, but I, for some reason, bumped the fan up to 3% on that first layer. Not sure how significant. And I believe the rest of it's the same. So let's look at some prints from third-party filaments, Hatchbox and AIO Robotics. Here's a 3D Benchy using the Hatchbox PLA. Now I can't say 100% that these parameters and settings were all tweaked exactly how I showed them here when I printed this, but the best parameter settings are the ones that I'll put on the profile on the link in the description for the materials that I'm using. Now again, I'm no expert at this stuff. I'm just pointing out what I see. I have to refer to my notes here. The one on the left has the Sindoh negative 0.15 Z offset in the script, a 90% first layer height, and a 150% first layer width. That's the one on the left. Now the one in the middle is the same, except the first layer width is 200% instead of 150%. Okay? And the one on the right is the same as the one in the middle, except it doesn't have the Sindoh negative 0.15 millimeter squish at the beginning of the script. But it is 200%. So the 200% definitely seems to put the lines further apart, but you have to adjust the amount of extrusion and the amount of offset, and all these things play into it here to get a different finish on that bed. So I just thought I'd point that out. And if you guys have comments, please leave them below. Here's another example of first layer width and the offset. Not quite the first layer quality I wanted. This is why it's important to have the first layer width and height set correctly. This was the AIO Robotics PLA filament. Finally, it was time to move on to PETG as a filament type. I had never used this before, so I had to purchase some online, and I thought this would be quite an experience, and it kind of was. So eventually, I ended up with two different profiles. Truth is, I think they're pretty much the same, but I purchased the eSun brand, and I purchased some Nova type brand. Let's look at this. In the end, I'll just show you what I ended up with, and if you guys have suggestions that'll make this better, let me know. It seemed like I had to set the extrusion multiplier higher. So this profile seems actually to emulate more an ABS than a PLA, but this was set higher. I tried setting it at like 0.8 and 0.9 and doing all these calibrations per these guys online, and it just wouldn't stick. It wouldn't work. It was terrible. So this is the best I could get right now without spending weeks and weeks. 1.08 on the extrusion multiplier. Even though I have a 0.4 nozzle diameter, it prints better at 0.5 extrusion width. I left the retraction the same as the other ones. My first layer height, you know, I mean, it squishes it down a little. The thing is, I will tell you this, it seems like if you start getting crystallization of the filament on the first layer, then you're squishing it down too much. So I don't want to squish it too much, because when I was doing that, thinking it was like PLA or ABS, it was getting all crystallized and messed up. And that's what the biggest eye-opener to me was to get this stuff to work, is not to smash it down like that. First layer width, I left at 100. Seems like you need more top and bottom layers with PETG. Oh, and a difference here. I get a much better print if I do 0.25 as my layer height instead of 0.2. Nothing significant here. These are different, certainly, and I got them from somebody online who was setting up for eSun, but they're not too far out of the norm. The temperature, this stuff is all over the place. I mean, some people say fan, some people say no fan. Your bed has to be this. Don't heat your bed. The only way I can get it to work for me that it won't warp and work well is to set this at like 80 to 90 on the bed. And again, remember, mine's off by 5 degrees, so I set it at 90. Hopefully the bed's now going to heat up to 85 centigrade. 240 and 245 on my nozzle, both of those worked okay. Cooling, I tried it, it warped up. I turned the fan off completely, just like I do for ABS. It worked fine. That's what I'm going to go with until I hear differently. This is all zero again. Now, here's the thing. Remember the negative 0.15 that was here from Sindoh? That kept messing me up. I kept getting crystallization, and that first layer was all messed up. So this is off, a bit, right? I mean, it's off by the 0.15 plus another 0.02. This is in the positive direction. It's actually pulling up away, the nozzle away from the bed for this offset in the Z direction when it starts. Once I changed that, then I started getting pretty good results. Again, similar stuff. Keep the fan turned off all the time. Speed's the same. Everything else the same. So let's go take a look at some jobs printed in PETG. Now this is certainly not perfect, but let me tell you about the excitement when this actually worked. I had hours and hours trying to get something to work, and I finally started getting a layer that looked like this, and I had to take video of it. So it's not perfect, but was the first time I got something PETG coming out of this machine that actually looked reasonable. And it wasn't tweaked at this point, but again, I was on my way to getting something good out of this machine for PETG. So here we are, the first project in PETG to come off this machine. I was pretty happy with it. Pops right off. Now this is actually the eSun gray filament in PETG. The reason this is significant is there's no warping down here in the corner. When I used the fan on this profile, that peeled off of there. And over a long job like this with both halves, it can cool. So this worked out well. I like the finish. The strength is there. It's good and solid. Yeah, that's not going to break. And this was a solid base on this. That came out nice. No real warping to speak of. Now, I did have a fit issue here with these pegs. They're supposed to snap in there, but this was designed for 0.4, and I wasn't worried about tolerances at this point. It was about quality and getting the material to print, so that could be easily fixed. Sometimes these pegs break off, and if you push them hard enough, you can, but there, see? But again, that has to do, I believe, with everything was designed for 0.4, and this was printed at 0.5. I can fix that. And just today, as I was working on this video, I printed another one of these Sony NPF camera battery wall mounts that I designed, but I did this one in the eSun PETG instead of ABS. Just wanted to see the quality. I love how it just pops right off instead of having to scrape it off. Let's just do a once over of the quality on this one. It's not too bad. No supports were used for these little cutouts I did here. It's very solid. Now here on the right is the ABS one that I printed previously. Color's a little different. the finish is, glossy on the PETG, but they're similar. Now the one on the right I scraped out with my knife a little bit, but notice there's no warping on the PETG on that bottom front corner. Pretty nice. And also today I went back and made another one of these because you can never have enough Arduino cases, right? But this was to test that the settings I had when I switched back to the Nova filament in PETG still worked. And it looks really nice. The strength is there now. And I'll show right after this why I say about the strength being an issue. The finish has a couple little zits on it and blobs, but for what I'm doing, it's perfectly fine. I mostly print in PLA anyway, so I'm happy with it. And this is why I was saying about the strength, because something about the extrusion width and the height on that first layer and everything, I just didn't have right on this one, and this is what happened. So I was happy once I got it tweaked in that this was no longer a problem and it was structurally sound. Well, I hope this has been informative and helpful, and if you have some suggestions on how to tweak these settings, please comment below and we can have a discussion on it. Thanks for watching.